Okay, so the last problem on the test will be a distributed load, and I think it'll be like this. It'll tell you to, hey, replace the distributed load. First, maybe replace the distributed load with 2 or 3 forces, and then take those forces and replace with 1 force and state where it acts on the beam. So we're not really worried about the pin at A and the roller at B. We just want to replace this distributed load with a force that has the same magnitude as the distributed load and that kind of has the same moment as the distributed load. So, what types of distributed loads have we done? Uniform distributed loads, linear, like triangular distributed loads, and one like this that goes from one height to another height. The magnitude of the distributed load is equal to the area under the distributed load. The location where you should put that distributed load is at the centroid of the distributed load. All right, so in general, I like to look at these distributed loads right here, these trapezoidal distributed loads. I like to think about those as a uniform distributed load right here with a triangular distributed load right here on top of it. So my first instinct would be to break this up into 3 distributed loads, replace them with 3 forces, and then figure out the equivalent. Do you notice, and if you didn't notice, this is perfectly fine if you didn't notice, but I'm going to actually combine this. I'm only going to say there are 2 distributed loads here, a uniform 3 that acts on the whole beam, and then this triangular load that only acts on this 4.5. All right, so first, let's take this pink distributed load and replace it with 1 force. Right, the force would be equal to the force would be equal to 1/2 of base 4.5 times height. Now be careful, the height is not 6. The height is that 6 to 3, so 6 minus 3, 3. And I should keep up with my units here, kilonewtons per meter. This is 4.5 meters. Yeah, so I'm left with kilonewtons. This would be what, 6 point, sorry, I don't have this written down, 6.75 kilonewtons right here. And then the other force of this whole uniform distributed load would be base of 6 meters. It's rectangle, so just base times height. Height of 3 kilonewtons per meter. That height. 18 kilonewtons. Sorry, and I would replace this at the middle. 3 meters from A. I'd replace this at the third of the 4.5 at 1.5 from A. All right, so that's kind of step 1, is replacing distributed loads with their forces. Now, if I ask you, and I am going to ask you, replace those with 1 force. Replace those with 1 force. Well, for all forces, the sum of the forces needs to be the same as that 1 force, sum of the forces. So the 6.75 and the 18 would be equal to that 1 force. That force, 24.75 kilonewtons. All right, but where should it act? Well, the moment of all of those forces, all forces, the moment would be equal to the 1 force moment. I could consider the moment about A, the moment about B, the moment about C, any point. I should get the same answer. So let's do the moment about A. For all forces, that 6.75 is 1.5 from A, creating a, we'll call it negative moment. The 18 is 3 meters from A, creating a negative moment. This would equal my 24.75 force. And it also, the distance d is what I'm looking for, and it would be creating a negative moment because I like to choose counterclockwise is positive, but all of these are creating negative moments. All right, I would get a distance d, 2.59 meters. Distance d, 2.59 meters. And that's all. Just say from A. Right, 2.59 meters from A. It's really just a weighted average. It's really kind of a centroid problem, but I think about it as summing the moments of all forces would be equal to the moment of one force. All right? So that was a good problem. Make sure you can handle triangular distributed loads, uniform distributed loads that are really a triangle on top of a rectangle. Replace them with forces at the correct locations, and then take those forces at those locations and combine them into one force, which that'll be easy. It's right here, finding the location of that force, which might be not as easy, but still not very hard at all. I really hope that this test is easy for you, because it gets harder. This is just statics. We're building on top of this for mechanics. It gets significantly harder after this test. So hopefully this was a good foundation of statics for you to move on to mechanics.